In our previous video, we looked at decision trees as one of the classification methods. It allows us to use lots of variables where we're not quite sure which ones we want to use. Of course, we should be informed when we pick those variables by doing some exploratory data analysis first, by looking at some inferential statistics, some data visualization, choosing a subset of variables that we think are most relevant, but still we may not be exactly sure which variables to use in the model. So the decision trees allow us to use lots of variables and have it identify what's the most appropriate. It then creates output for a decision tree that looks like this, which goes through scenarios and says, how do they respond to this question? If they responded this way, then this way to this question, that puts them in this group, which then puts them in this particular label. And if they responded this way, it puts them in this group, so that's another label. So that's how a decision tree works. The challenge with the decision trees, as we saw in our previous video, is that they are highly susceptible to the order in which the information is loaded and how the data is split into test and train. Now, when it comes to that decision tree, we want to improve the model. And one way to improve the model is to run the decision tree many times, because we saw in our previous video, when you rerun it, you get a different accuracy and a different model. So what we're attempting to do is find the best fitting model to our scenario. And we do that with the multiple decision trees. The benefit of this averaging of decision trees is what the random forest method does, is it can improve accuracy while controlling for overfitting. So we haven't seen it yet in our videos, but in our videos related to forecasting, we're going to talk about overfitting. So just a little aside, here is, let's say, a linear model. We fit a line to this data. It is underfit. You see how this line does not explain the relationship between these points? An overfit model perfectly explains all variability in data. You can see if we made a crazy line like this, we could explain why the data points go down and up and this way and that way and everything in between. But the problem with this overfit model is while it explains all these data points really, really well, it doesn't explain what's going to happen to the new data point that we don't see yet, whether we're forecasting into the future, or in this case, if we're doing some classification models and we have this data point, we're trying to figure out what's the appropriate label. So what we want is we want a model that is not underfit. We want one that the model well explains the data, but we don't want it overfit because that's a lot of extra effort for a relationship we can't really explain to our stakeholders. And while it fits the existing data really well, it may be terrible for future or additional data points. So we're looking for a well-fitting model like the one you can see here if we're looking at a polynomial of degree 2 for this data set. Well, the same thing is true with random forest. What we're trying to do is create a better fitting model than one random decision tree creates. And we know that every time we rerun the decision tree, we get a different model that fits a little different, has a little bit different accuracy. So the idea is to improve the accuracy, but not overfit, by averaging the multiple decision trees together. So that's what happens with the random forest. We're doing the decision tree over and over and over again and averaging the results together. So the idea is the more decision trees that are generated, the more accurate the model. Now, if you leave it to the model built in Python by itself, as I'm moving the wrong things around, just moving my face, the default is 100 in terms of the number of decision trees it averages together. What you want, if you want to manipulate that, which you totally can, studies show that you need to have at least 20 decision trees, but that the return, the gain in accuracy after 20 is quite minimal. So you can let it run the 100 default trees and average the results together, but don't ever lower it below 20, okay? Because you need at least 20 before to actually improve the accuracy. So we'll leave it for the most part, I think, at the default 100. But if you have a really, really big data set, then what you might find is that that takes a long time to run. And so you could lower the number of trees below the 100, just not below 20. All right, so let's look at how this works. Now, the downside to random forest, just to make you aware, is that we could visualize the decision tree, we could see it, but because the random forest is an average of 100 of these, there's no visual. So we can use it to predict labels, but we can't actually do a visualization like we have with the decision tree. So let's do our random forest. All right, so just a reminder, if you are working along with us, you can find the workbook at drstephpowers.github.io/BIA. Keep moving the wrong things, move my face back down. So drstephpowers.github.io/BIA, we're doing the classification workbook that you can find right here. Go in, you'll need to not only open the workbook in Google Colab, but you'll also need to put the Excel files into your Google Drive and link them together. All right, so let's go in. Let's look at random forest. If you want to see how to access that, how to link them together, check out a previous video. I'm not going to do it for the 50 millionth time in this particular video. All right, so let's do some random forest. So what are we going to need? Well, if we are doing a random forest with a binary classification, so it is south, not south, it is yes or no, so two options for our classifier, then we can do confusion matrix, precision score, and recall score. For all of our classification models, we can check it with the accuracy score, which is the percentage that it correctly labeled. And then we're going to have it do the train test split. So we're going to need our model selection so that it decides from our data set which ones are in the testing and which ones are in the training. And from the sklearn, and then we need the one that's particular to this classification method, which is going to be sklearn.ensemble, and then we're going to do random forest classifier. Okay, now I'm just going to check and see, because we can do a comparison if I did the random state for the here. Okay, so in our previous video, we looked at decision trees. I believe I did a run here, where the random state for this test train was 1900, and that gave us an accuracy of 69%. So we'll just hold on to that information, and I'll use that same random state for our random forest, and we'll see if we do any better. Okay, let's find out, where did that go? All right, so we're going to import our packages. Here we go. And we'll just take a look at our data frame. This data frame already has that variable called south. If you are just loading that data frame for the first time, you will need to add that variable south by creating a copy of the question 23 column and replacing it with where the 2 is 1 for south and the 0s for the north and the east. We don't have to do that. It's already in our DF2. So I'm going to then make this random state. Of course, what was that number? 1900? Let's go back up and double check. Mm-hmm. 1900, right? You can pick any number you want. It's just this random generator tells it where to start. And so if you want to get the same output as previously, then you got to use the same random state. So my apologies for the scroll. Okay, so what we're going to do is have it pull the training, the testing data from our data set here. We're going to use question 2, which if you recall was the part-time, full-time. We're going to use question 13, 14, 15, 18, and 20. And these were the questions in our bargaining survey about satisfaction with the amount of hours worked, the time of day, the location, whether they felt the workplace was safe, and whether the workplace was inclusive. So can we use those questions to identify who is working at the south location? So we're going to run that to create our test and train data. And then, like every other classification model, we need to specify what is the classification model we're using. In this case, we're doing random forest classifier. We'll call it RFC for short. You can call it whatever you want. Just make sure when you go and fit and predict, you are using that same name. So we are going to fit our random forest classifier using our training data, X and Y. And then we are going to predict using our random forest classifier on our test data. So here we go, and we can see in this scenario, it has identified 3 locations, 3 responses as being from the south, and the rest not. So if we run the accuracy here, we can see that it is 69%, and let's just go back and compare. Not 23, let's go find the previous one. So south, same variable, same random state starting point. You can see that this method gets us a similar accuracy of 69%. Okay. The previous confusion matrix, when we had 1 decision tree, had 1 false positive and 3 false negatives. With our random forest, where it's simply doing 100 decision trees, we might have gotten a little bit. I think that might be in 61.2. This 61.5 might have got a little bit there. Is that right? Is that the right? Maybe that's not even the right spot. Nope. Let's keep going. No, that's the same. Okay. So what we're going to do is create our confusion matrix because we have a binary predictor and we can display that information. So you can see here that we essentially have the same, where we have the same error, right? Same 1 false positive and 3 false negatives. So likely it's actually classifying exactly the same with 100 decision trees as it did with our 1 decision tree in this particular case. Okay. The bigger your data set, the more that averaging of those decision trees is important because, again, decision trees are highly based on what gets pulled into the test data and what gets pulled into the training data. We can see here, because we have false positives and we have false negatives, that neither the precision or the recall is going to be 100%. We can see because of those false negatives, the recall score is lower than the precision. So how about you? Why don't you try creating a multi-label classification model using question 2, 13, 14, 15, 18, and 20 to identify location question 23. So create a random forest model that instead of predicting south, not south, predicts north, south, east. Okay, so pause the video and give that a try. All right, so to do that, we are going to first, we would have all of our packages. Now I know you just did those, so we don't technically need them, but it's always good practice to put them all together in case you're looking at a chunk of code and you want to rerun a portion of it. Now notice this confusion matrix and the precision score we can't use because it is multiple labels, so let's remove that. And then as we're looking at the next stage of the process, we are going to pull our train test. So let's put that in, X train, X test, Y train, Y test, train test split. We're using data frame 2. We're using question 2, 13, 14, 15, 18, and 20. We're going to be predicting question 23. I'm actually going to use random state 200 because I think that's what we used for our decision tree before, and so we can do a comparison. All right. Then our process here is that we are going to need to call our model, fit our model, predict, all the same steps that you do with every classification. Make sure here it's doing random forest. Then we need to fit that random forest. And predict with the random forest. And then we can test the accuracy of that. Can't use precision or recall or a confusion matrix, but we can do accuracy. All right, load our packages. Separate out our data into test and train. Call our random forest classifier, fit it against our data, predict our values. So notice here we're predicting 1, 2, 3, not just south, no south, but north, south, and east. 1 is north, 2 is south, 3 is east. And then we can look at accuracy. How well did it do? And the accuracy of this model is 61.5. Let's just go back to our previous video. Okay, and we were having a model here about the same. Okay, so based on the size of the data set, how much variability is in it, then doing 100 decision trees seems to be giving us about the same results as doing 1 decision tree, which is great because then you can use just the 1 decision tree and then you can have that visualization to show how it's broken down. If you have a much bigger data set, a much more variety in the data set itself, then that random forest allows you to get an average of those decision trees where there might be a lot more changes every time you rerun it.